All right, guys, so settle down.
This came from your favorite class, right?
Okay, today's lesson is not very long. We're just going to learn the trig derivatives, okay? Now,
Hi, Mikey.
for the most part, you need to memorize the sine, the cosine, and the tangent. I'm going to show you the other ones, but you'll need to be able to apply them, but I won't test you on the other ones, okay? So sine, cosine, and tangent. So the derivative of sine equals cosine, and the derivative of cosine is negative sine. So you do need to memorize that. Make sure you remember which one is the positive or the negative one. Okay.
Not negative, right?
Wait, we still need to know like what minus negative one.
So you need to know the main Pythagorean identity from last year is the sine squared x plus the cosine squared x. That has to be equal to 1. That's really the only one that shows up. It's not, we're not proving identities like you did last year, but you might have to apply some of the rules. So you still need to know 1 over sine is, which one? Cosecant, and 1 over cosine is secant, and 1 over tangent is cotangent. So you need to know those rules, and you need to know the Pythagorean identity, and those are the basic ones. Okay, so we want to find the derivative of each function. So this first example, we have to use what?
Oh, the power rule.
Well, power rule, and it's x squared times the sine of x. So remember when we did the product rule in the past, and I said, well, you could FOIL this out, and then you could do the power rule. This is an example where we don't have that as an option. There's no FOIL, right? We can't distribute it. We can't do anything. So we have to use the rules for the trig, and we have to use the product rule. So the power rule is for the exponent. The product rule is when you have two things multiplied together. So we actually have both here. So if I make this u, and we'll make sine v. So what's u prime, and what's v prime? So we get 2x. So that's using the power rule. And now the derivative of sine, so I just told you that's going to be positive cosine. Now when I do the derivative, so when I want to do y prime, now we're going to use that product rule, which is what? Okay, so u times v prime. Here, I'll just write it out. U v prime plus, yeah, again, it doesn't, you know that you can switch them around. It doesn't really matter, commutative property. As long as you just take derivative of one, keep the other one the same, and then plus the other one. So what do we have here? We have x squared times what?
Cosine x.
Just cosine x.
Yeah, sorry.
Does it matter which one's U and V for this problem?
Nope.
Like these types?
It doesn't matter. You could switch to u and v. Times, now it's v, sine x, times u prime. I'm actually going to put the 2x in front. Just, I don't want to accidentally multiply the x into 2x to make that 2x squared. Because remember, it's the whole thing, sine x times 2x. So if we have something like that, just put it in front like it's a coefficient. Can we go any further? I mean, we could factor out an x, but that's not going to simplify anything. So we're done. This is it. Okay? All right, next one. U will make cosine, and v is going to be 1 minus sine. So this we have to use the quotient rule because we have something in the numerator, something in the denominator, and we can't simplify it. So what's u prime? Negative sine x. And what's v prime? Okay, so what happens to the 1 now? 0 minus, what's the derivative for sine? So it's just negative cosine x. Are we okay with that?
But in the problem, v is equal to 1, right?
V is the whole thing 1 minus sine x.
Which is equal to cosine.
Ah,
Oh, no, never mind.
that 1 minus sine squared would be cosine squared, but we don't need to.
Wait, how do you get 0 minus cosine?
So the derivative of 1 gives us 0 minus, and then what's the derivative of sine? It's cosine, so that's we got negative cosine.
Could you solve this using like conjugate?
We can't.
You can.
Sorry, it's just really good. Why is it negative cosine, not just regular cosine? Why is it negative?
So picture just this part. What's 1 becomes a 0, and the minus sign is still just minus. But what's the derivative of sine? So if I have 0 minus cosine, that's just negative cosine. Did you put an extra minus in there or something and make a plus?
I'm not sorry, the bottom of negative cosine.
Right. Yes,
Which is
that's what I'm
like-
talking about too.
I thought you were
This part.
Okay, yeah.
Because 1 becomes a 0 minus,
Oh.
and the
what-
derivative of sine is cosine.
The whole thing.
So the whole thing is just negative cosine. Good?
I just memorized
Okay, quotient rule, what is that?
the question.
Okay, so
I just did it the other way.
that's fine. You could do it that way.
And then
Take high, D low. Now this can be simplified further. What can we do in the numerator? Well, we can distribute. So distribute this sign to these two. And then here, what happens if you have a cosine and a cosine? What's that going to look like then? Cosine squared. So we get a negative sine x plus a sine squared x. And then we have two minuses, so that makes that a plus cosine squared x. Now remember I said there was really only one identity that we needed to really apply. Sine squared plus cosine squared equals 1. So what do we...
Cross out from the top and the bottom.
Exactly. What do we notice that we have in the numerator? Something that will cancel out something in the denominator. Since this
How fancy.
is 1, so...
Oh.
no.
It's so
It's-
nice when things just work out like that.
It's fine. I don't think he'll actually be listening today, but...
Alright, if you're listening, go ahead.
So negative sine x plus 1 is the same thing as 1 minus sine x. So I'll be able to cancel this, and this becomes 1 over 1 minus sine x. Questions? Okay. So if we can simplify it, keep going, simplify it. But you see in the last one, there was nothing really to cancel. You don't want to do stuff like that unless you are able to cancel stuff out. All right, simple harmonic motion. Have you done any of this? No? Okay. It sounds nice. Harmonic. So when you get harmonic motion, picture something like a spring, a weight hanging off of a spring, and the motion of it like basically bouncing up and down. That's harmonic motion. So let's say we have that, and the position is 5 cosine of t. Again, position is where the actual weight is at a particular point in time. So if we want to find the velocity and acceleration, what will that be? Good, so go ahead and do that. Oh, it's not too bad. Okay, what does the 5 do? Doesn't go away. Okay, if it were 5 plus cosine t, it would go away.
Oh, no, it's...
But if it's a coefficient, so I know 5 is just going to get multiplied by whatever the derivative of cosine is. The derivative of cosine at the top we said was, that's the negative sign. So we get -5 sine t. And then what about? Right, now we want to take the derivative of that. Again, the -5 doesn't go away. The -5 just gets multiplied. Well, what's the derivative of sine? Regular cosine. So we get -5 cosine of t. Good? Any questions?
It's like changing cosine x to negative sine x.
It's just like beta kind of, you think about it? Like it's just like a part of a cosine?
Yeah.
Yes, because cosine is a function. It's like natural log, like ln of x.
Yeah, you can't have a
You
cosine
can't have an ln without something right after it. Same, like you can't have a cosine without.
beta or anything, yeah.
Is there no 3.6?
There is a 3. There should be a 3.6. We have 3.5 now, or this is 3.5, then 3.6. 3.6 is the big one. Are you missing that in your notes?
I have 4 pages later and then 3.7.
Okay, I'll take a look. That's really weird. Okay, it's good that I know this now. Okay, remind me, I'll look at your packet. Jerk.
Ooh,
Jerk is,
oh, I remember you.
so when I talked about, like, what creates motion sickness is jerk. Okay? I told you that before because, exactly, so not everybody gets motion sickness, but this is what causes it. If you're not, it's when you're not expecting it, right? And there's that sudden change in acceleration, that's what's causing your motion sickness. And that's just the derivative of acceleration. So that is the third derivative of position. And that's as far as we go in terms of movement. We have position is the one we start with, velocity is the first derivative, then acceleration is the second derivative, and then jerk is the third derivative. We don't do that much with jerk. Yeah.
I mean, for most of the
I
times
don't
we've done it,
know.
just be 0.
I'm so confused why it didn't print.
How
I'll
many
look.
pages is this one?
This is just, this should
Just
just be
2.
2 pages.
So does it start outside, inside loop?
Yeah.
It
No.
starts right here.
I'll-
Yeah, I don't know.
Wait, I
Ours,
think
mine
we're
just
missing
goes
a
all the
page.
way
We're missing 23
until
somewhere.
3.7.
We're missing 23.
Yeah,
This
bro.
case, how did you manage that?
I have no idea because I printed it right
No,
from my
we're
computer.
like genuinely missing one page of the total.
Okay, I'll figure it.
Okay.
Okay.
That's so weird.
Like we're doing it.
So you're missing 4
Stage.
pages. It goes to
Stage.
3.6.
Okay, so
22,
in this example, in the example of gravity, if you have gravity as negative 32 feet per second squared, what would be the jerk? Well, it'll just be 0 feet per second cubed. Because if this is constant, what's the derivative of a constant? It's 0. And then what about the jerk from example 2? What would that be? So if acceleration was -5 cosine t, what would be j of t? So this is going to be -5, and then what's the derivative for cosine?
Sine. Negative sine.
Negative sine.
No.
So we,
Thanks for telling us, man.
all right, questions?
Shana got it wrong.
Can we continue on, like, is it, like, can we continue on forever with the derivative of this?
Yes,
Yeah, because they always switch.
yes. Sine. So basically, and I believe there's a homework question, which will ask you, I don't even remember, like the 700th derivative of sine. Okay, so what you look for is a pattern. Basically, it's eventually going to get back to where we started.
And then you look
So-
at that, or divide it by.
Is the pattern by 3?
Oh, I know you have to divide them.
So like if you start with sine, just so you can,
It repeats every 3.
so if y is sine, then y prime would be cosine. and then y double prime would be
Negative sign.
negative sine,
And y triple prime.
and then triple prime would be negative cosine, and then the fourth derivative, sine. Okay, so it takes 4 derivatives to get back to where you started. So this is kind of like I. When you talk about like I to the 17th power, we know I to the 4th is 1. So if it's I to the 17th, it's 1 more than a power of 4, if you will.
What is this like? What's the one?
Why?
Yeah.
why
So if
is-
I asked you for the 17th derivative of sine, okay, so the 16th derivative would be sine, so then the 17th would be cosine. Okay, so there's a problem like that on the homework, and yeah, that's why I wanted to just, this is kind of just a side note, because you do have one. Oh, did I go too fast?
No.
All right, we just have one more page.
So then 3 points. What is the?
I'll have to make sure I print them for
So it
next.
starts on page 25.
I have no idea how that happened. I'll have to
That's
make-
so weird that some of us have it and others don't.
But
And I
what's the
printed
inside
it
outside?
right from my computer, so does it make sense? to
Maybe
me?
the office ladies together.
They, Barbara sometimes can scheme you.
She's the nicest one.
Sometimes she's a schemer, but sometimes she's a helper. But like,
She's
she's like,
okay.
but she's
All
like
of
no
them
more
are kind of rude.
Did we get it?
She may come in.
Okay. So which ones did I say you have to memorize? Sine, cosine, and tangent. They're all down here.
So it'd be the
Let's-
quotient rule.
What we could do is quotient rule, or we could do, well, we don't have what's called chain rule yet, but
Or the power rule.
we could find all of these with just knowing sine and cosine.
Oh
my
God.
Were you not here for the past 10 minutes?
I was like working on it. I was very confused. I thought everyone was talking about missing this part.
Hey, Noah.
It's okay, Noah.
I'm sorry.
You get it now?
I get
So
it.
like, drop it.
Okay, King Feldman.
Okay, let's
If I listen to like.
let's focus on what we're doing, and I promise we'll make it right with the packet. Next
You know what
class.
you should do? You should just print out one piece of paper and restaple all the time.
Okay, so we are going to derive the derivative for tangent using sine over cosine. So what does that look like? Well, remember, if this is u and this is v, what would u prime and what would v prime? Positive cosine. Remember, sine goes to positive
I
cosine.
meant the other one.
Cosine goes to negative. I know, it's confusing, but eventually you've got to have that memorized. Okay, so it's low d high, so cosine times, so derivative of the top is cosine. Take high, so that's sine. D low, so that's negative sine x. All over cosine x squared. You okay with that?
Because you're gonna have one.
This is the one that I said you have to know, because what happens in the numerator, we get cosine squared plus sine squared. And so what's that give us? What's that give us? 1 over cosine squared. And we just talked about also the reciprocal functions. 1 over cosine is secant. So we get secant squared x. Okay, so sine, cosine, I honestly think if you can memorize tangent, it's better than having to derive it each time. Okay, but you could. It would take just less than a minute to derive it.
So we just.
So you also need to know this one
So derivative of y is secant squared x.
right here. This is, yeah, you need to know. So derivative of a sine is cosine. Derivative of cosine is negative sine. Derivative of tangent is secant squared. Now, these will show up on like your homework problems, but I'm not gonna test you on them. If you wanted to derive secant, you would do 1 over cosine and do the quotient rule, and it would work out to be secant tangent. But those are the 3 that I need you to know.
You don't need to memorize it, you can just derive it.
You could just derive it.
Yeah.
The only ones you can't derive are sine and cosine. Those you have to know.
Right, because that's
Right, because there's.
Why not?
That's like a thing you do.
So you need to know those 2, and they're all based off of those 2. Okay, so find the equations for the lines that are tangent and normal to the graph of tangent of x over x at x equals 2. So for finding the equations of the lines, we need to know slope and we need to know a point and a slope. We have 2. We can figure out the y coordinate by,
Plug it in.
and this is a calculator okay problem. So,
So what do you guys get?
oh, radians.
Why radians? Because it's tan. Yeah, why radians?
Well, I have it on my computer. Negative 1.092. Whenever we're using calculators, just make sure you always go to 3 places for calculus. So again, you can truncate, which means just take the 3 that you see, or you can round. Okay, so I have a point. The point is 2, comma, negative 1.092. Now we need to figure out our slope. How do we figure out slope? Derivative. So we want to find f prime. So if this is u and this is v, u prime is secant squared. And what's the derivative of v? The bottom is 1. Okay. You guys go ahead.
You do that.
Yeah, go ahead.
Wait, how do you multiply x into secant squared x?
You can't.
So it's just x.
Okay, so the good news is we don't have to actually go any further with this problem because what do we want? We want to find the slope when x equals 2. And this is a calculator problem. And in fact, there's nothing really that's going to simplify.
Yeah.
Okay, it's a mess. So we just want to plug in 2. So it's going to be 2 times secant squared of 2 minus tangent of 2 all over,
Oh, that's how you want to do it?
do you have a better way?
No, I just figured it out with x. What? Like I just like. Hey, you're good. Don't worry about it. Alright, we're good.
Okay, when we're doing secant squared of 2, how do we plug that in? I'm sure you're fine with plugging everything else in, but when we're doing secant squared, yeah. So we're going to do 1 over cosine of 2 and square that, right? How do you, so obviously there's no secant on our calculator. And if we have a secant squared of 2, what do we do to plug that into your
it's
calculator?
secant 1 over what's it called?
1 over what's it called?
Cosine?
Cosine.
Cosine or sine?
So I'm going to type in 1 divided by cosine of 2 and square that. I'm saying just this part, that's what you would do to plug in. And then we multiply that by 2, and then we subtract tangent of 2, and then we divide the whole thing by.
And then square.
So again, you can plug this all into your calculator at once. I just need the approximation to 3 places.
And then n is equal to
5.774.
Oh, you're just gonna trust the first one you hear?
I don't know. Somebody verify. I don't have my calculator in.
You have
I'm not.
Alright, Alex is wrong.
I have a calculator in my back pocket.
Oh, is that right?
I promise.
That's not right.
That's not right? You got something different?
I got 4,000, 4
I got that.
million. That's not
All right, now I'm really worried.
In this case, if you're doing my calculator.
We have the time. Well, let me just confirm here.
I got 6.
No, you're wrong.
Alright, I think I did the first.
Watch everyone in the class.
I got 3.43.
Okay,
Yes, that is the confirmation.
I'm just gonna do this part first.
I didn't do my parentheses.
Okay,
I got it wrong.
that is just the secant squared of 2.
And multiply by 2.
So we're gonna take that
Oh, I didn't divide by 4.
times 2
No.
minus tangent of 2.
Oh, I got 5 plus 3. Then what?
So then I multiply that by 2.
I thought you were just asking for that part.
Oh,
No.
no, sorry.
Oh,
It's okay.
that's
So you got that part right. Is that what we got? 3.433?
Wait, I have a question though.
Yeah.
So if tan x is secant squared x, and we have secant squared x,
I got
what if we do x over, like, if we were to change tan x to secant squared x, like, see here, we have tan x.
See if you can write the equations.
Oh, like we did. Now we're replacing it with 5.
No, we're not taking the derivative of
This is taking the
Wait, but we don't have 1.
No, you
mean we don't have
writing.
y? We found y. Remember at the very beginning?
Oh, that is 1.
We found the point. Let me. I think you're trying to do a derivative within the derivative, but yeah, we just want to do that one time.
In this case,
Yeah.
the slope that we found is that for the tangent line or is that?
That's for the tangent. So, okay. This is what we get in point slope form for the tangent. Again, I'm so happy that I'm recording this. Okay, so,
In this case, if you have class,
normal.
if you have class talking while you're teaching.
Oh, you have it?
It's just
that, and then
1 over 8.
Okay, so what is that? What is -1? So when I'm talking about the normal slope, I don't want to have a decimal within a fraction. So tell me what negative, no, it's not proper to leave a,
Is it the inverse?
yeah, so take this and plug that into your calculator to 3 places.
It's -2.
That's what I want to see here, because that's how it's going to look.
Is it actually -2?
No, negative 0.2.
Negative 0.291. So that's what I'm going to use in the equation. Yes.
When I plugged in, I put 3.433 and then I did the inverse of that. It gave me a positive number.
Impossible.
ow.
Because you have to have the opposite. You have to have -1 over that, right?
Yeah. I mean, so get my answer. And then the answer inverse.
This is to the -1 power. It's not the inverse. -1 power will just do 1 over something. Okay, next. Second derivative, I think this is the last one, right? Second derivative of secant. Anybody want to do that? Anybody? Any volunteers?
Wait, I'll do it. I don't know.
Oh, do you want to try it at your seat first?
Shouldn't have prepared to be embarrassed. In this case, when she gets it wrong, just laugh.
Aww.
Just
No.
laugh.
I don't do that. That's not my style. I can't. Now would you like to-
Look, she's laughing. Wait. Come up with a nickname.
I wasn't laughing at something you did mathematically. Maybe because you're left-handed. Maybe that's
It's absolutely the reason.
okay.
Can I find the first prime and then the second prime?
Yeah. That's
You're
exactly what
about to
happens.
click something.
No.
It's okay. Just
Oh, it's the mouse. Everyone.
maybe you're.
Oh, wait.
Okay. What's the first derivative?
Okay.
Oh, Shane, you put a dot on the bottom of the page. That's annoying.
I actually
Too bad.
did. The one's hot.
And there's another dot.
Oh,
After my phone is 9,000 more.
so you don't,
Mm,
She's starting to laugh.
no, okay, if you want, you could go the long way, but remember, you can just refer to the ones that are in the table above.
What are you thinking?
what? Oh,
Here.
I don't like it.
Walking away.
If you, look, in that box above,
All your work is got erased.
what's the derivative?
She's more right than you guys. You didn't even walk up. Secant x.
Oh, jeez.
All right, secant x, tangent x.
Wait.
And then it's.
Just look in the box, look in the box. I didn't highlight it, but I said that you're
Oh,
gonna have some
this
problems on
one. Okay,
Homer.
okay, okay.
So just refer to that box. If you wanna highlight them, I just wanted to highlight the ones that you had to memorize, but know that you can refer to that for Homer.
And then it's secant tangent and then secant square.
And how did we get that?
Because I took secant again, and then secant again, and then I took tangent, and then it's secant square. Oh, no, you can't do it like that. You have to do the product.
Gotta use the product rule.
I got secant cubed.
Because u prime
Squared x.
is gonna be secant x tangent x. And what's v prime?
Secant squared x.
Secant squared x.
And you just do the product rule with those.
Yeah, so
I
now
just-
what's that look like?
Secant times secant squared x plus tangent.
So secant x times secant squared
And then the tangent
plus tangent x,
times secant squared, secant x, tangent x.
right?
And then you got secant.
So secant to the third
plus secant tangent squared x.
So that's your second derivative.